Hello, welcome to Teach Meet Dorset. My name is Jonathan Furness and I'm the acting head of Kings Road Primary School here in Essex. You can follow me my Twitter at Jonathan Furness or go to my blog site www.jonathansblog.net to find out more about the work that I do in schools with education and technology. Okay, so I'm going to talk to you about the Raspberry Pi programming in primary. I'm going to try and keep it to 7 minutes, although that will be quite tough going. But you can see that many of you will have heard of a Raspberry Pi device. It's a small computer and it's been in the news quite a lot, so it's already got a lot of media attention and many people understand what it is. It's quite a seductive computer. It's cheap, it's affordable and requires no specialist equipment. So USB keyboards, mouse, will already be in the household, quite likely. You'll probably be able to find an old mobile phone charger that you can use to power it. It connects to TVs via the HDMI connector or DVI connector to any modern computer screen. The storage is on SD card, and everybody has an SD card these days in digital cameras, video cameras. So you could just borrow one of those, load it up with the operating system, and rather usefully it comes with several programming environments, one of which Python, Scratch, Squeak, that are all ready to go and help you get you started. Look, here it is. It's very big on my screen, it's probably even bigger on your screen, but actually the whole computer is no bigger than a credit card. So you can see it has several input and output connections, USB, Ethernet. It's got video out, audio out, and there's the power connector on the front face there. Okay, so how does this fit in the primary curriculum? Well, Michael Gove has, for a change, said something really quite useful earlier this year at BET in 2012, and he instigated a change in the ICT curriculum, and it's been a long time coming. Let's be honest. Over the last 15 years, we've been teaching children how to use computers and how to do things with them, but very little about how they actually function and why they function in the way they do, and actually making anything. You know, there's very little in the ICT curriculum as it stands about making, and that's about to change. The Raspberry Pi work that I've been doing with the children in my school is about contributing, making, developing, problem solving. You can see that I've quoted from Computer Science, a Curriculum for Schools document, a very, very useful document. I'll come to that later in my presentation. It says, computer science is deeply concerned with how computers and computer systems work and how they are designed and programmed. Absolutely essential. So how do we get started? Well, children have this fascination of finding out things that they don't already know. And one of the best activities you could do is to set up a computer, an old computer in the corner of your classroom. Hopefully it's still working. Plug in a screen, plug in a keyboard, mouse, and the children absolutely love it when you go to that computer and start taking it apart, taking the covers off, taking the motherboard out, taking the hard drive apart, looking at the inside of a computer, what actually makes it tick. We then looked at the Raspberry Pi and looked at, okay, so we've got some components in a desktop computer and we look at the same components in the Raspberry Pi. And of course they always ask, so how does it really work? What is it that tells the computer what to do? And that's when we talk about programming languages. Interestingly, at Key Stage 1, taken from the document I talked about a moment ago, it says that a computer program is like the narrative part of a story, and the computer's job is to do what the narrator says. Computers have no intelligence and so follow the narrator's instructions blindly. Computers typically accept inputs, follow a stored sequence of instructions, and produce outputs. And that really sums up, particularly for Key Stage 1 and Key Stage 2, how to write a computer program. And we use Scratch in Key Stage 1. I suppose in my mind I doubted, so what could Year 1 and 2 children actually do? How much programming could they actually do and understand? Well, look, here's a very visual programming language, Scratch. You can see on the left hand side all the instructions of things you can drag and drop into your program, and you just simply sequence it into a story. And so here's Lucy's story of sending a rocket in and around space. And some of you in the audience will probably spot that that's not too dissimilar from Logo and the programming languages that we used 20, 30 years ago. 30 years ago, gosh. So, and you can see those instructions. You can see how they can be customized, and actually children can explore what to do. Well, look, then we looked at what our Key Stage 2 pupils might do. We looked at Year 5 and 6, and I thought that they would just carry on and use Scratch, the visual programming language, but they really shocked and surprised me by saying, no, look, we want to do that language where you type commands into a computer and it does things. It does things for us, and we can see it instantly. So we looked at the print command to put information onto the screen. We looked at maths calculations, and they were fascinated typing in numbers and getting the computer to do maths. And the computer was doing no more than being a calculator, but it was rather more fun and more seductive than using the tool that they're more familiar with. We used variables, and they love setting fruits to values, and bananas and apples, and then they could experiment using these variables to do calculations. So we had lots of bananas and apples being added together, and the children could see that you could get 13 and so forth. So we looked at individual commands and instructions using this language called Python. We then looked at how we make a sequence of commands to form a program, and this is more automated, so you would already have preconceived what it is the program should do. And you see on the left hand side, this is the narrative, this is the story. So children were using their own words and their own language to describe what the program should do. On the right hand side of the screen, you could see this is it translated into the Python language, the Python programming language. And if those instructions were added to an environment like Python, it would actually do something. There's the program in the terminal application that we used on our Mac computers, but it wouldn't have to be on Mac, it could be on Windows PC. The Python is available cross-platform on Windows, Mac, Linux, and we just use a text editor actually. What was interesting is there were no buttons or whizzy, flashy, draggable objects in this process at all. It really was just typing into a computer and seeing the real bare bones of what programming really is. So I then set the tasks. This is all about problem solving, so very cross-curricular, looking at maths, science, technology, ICT, and I said, okay, we're going to make these programs do something actually useful to us. So what could we do? Well, we looked at function machines, and we thought actually a function machine is something that does something. We could convert temperature, we could look at converting speed, any length, weight, capacity. Children even thought, actually I could make some maths games here to help, and some tools to help our younger children to learn their times tables, for example. I've got a team of students who are looking at word suggestion tools, which is a bit like a thesaurus. I think as they move on, they'll realise that it should be a database, but it's only through that exploration and investigation that they are going to find out these problems, create new ones, and solve them. Fabulous. Okay, so here are the key skills in programming. I won't talk you through all of them, but you can see that it starts with modelling to children and looking at examples that already exist in everyday life. And through that process, you then start decomposing it into smaller chunks and smaller components. That leads you on to designing and writing the programs. That's the fun bit. And of course, more problem solving is still to come, as the programs that they've written don't actually function first time around. So then you've got to do the exploration of, so why is it not working? Testing and breaking down your program into smaller chunks and making bits of it work. And then the crucial bit is to actually say, oh, that's why that's why it didn't work. And actually recognizing that programming has to be very precise. There is a syntax that needs to be followed, and that's the reasoning behind what we're doing. So this is the document that I wanted to share with you. I would strongly suggest that you go away and download it if you're interested in how to organise computer science in your schools. This is a document that lays out and sets out the curriculum components in key stages 1, 2, 3 and 4. There's the web address there, computingatschool.org.uk. That document is absolutely valuable. I'd go away and get it right now. This project continues in my school. I'm working with a lecturer in the University of East Anglia, and what we're working on is putting together a package that will support schools in developing programming across the curriculum. So watch this space, and I'm sure I'll have more information and more things to share with you all as we progress into 2013. Thank you very much for listening. I'm sorry it was so brief. I'm sorry that I'm not with you to enjoy Teach Meet with you all. But thank you for listening, and hopefully I'll hear from you and see you soon on Twitter. Thank you. Bye for now.